Right then, here we go, setting off for a new live stream. Right, so welcome back, all people on the stream, and I'm again completely not prepared for this. Just started it yet, so let's get the music running. I really enjoyed it. Like all the tools remember my settings. This is very, very, very convenient. I mean, it should be like that, but it's not always like that. If you're a developer yourself, you know that things should be always easy and remember itself, but they don't. Alright then. Let's go back. Well, normal studio, please. Alright, so this is my live stream. Okay. I'm rolling. That's the most important thing. Let's get the chat out here so that everything is set up correctly, so that we can start here doing what we do. Testing out data, checking that everything works and everything is good. Now, this stream today is gonna be different than what I've actually wanted to do, because I'm missing like a big part that I want to get right from the beginning, so that we later on don't get any issues with like file systems. And the first thing that we're gonna do is, after I've talked a bit, we're gonna start checking what I've implemented in between, and then we're gonna get started maintaining my Trello board that I haven't maintained for a while, and then we're gonna start implementing stuff and do a bit of file system today. That's like the goal of today. Write a flexible file system. Okay, so the first thing that I'm gonna do here quickly is pause the music again and check that my stream is rolling, what I've implemented in between. Okay, so my stream works like it should, that's good, so we can directly start on and continue. Alright, so let's first talk about what I've done in between the last stream and now. I've done a few things, and these are all the Git changes. I've now opened this up in Visual Studio Code, because it's probably better, and if it's not committed here, then it's good. Alright, so how do I want to start to talk about this? Let's get the full path here so that I can see what's going on. Alright, so last time we integrated a few libraries, including FreeType, and we also talked a bit about how about getting glyphs into there, and that we also want to use STB rec pack to later on create font atlases that we can use for debug drawing, because it's the first thing that I want to do before you do any integrations like UIs, rendering 2D, 3D. I don't care about what, but I first want to have a rudimental debug text rendering and debug line rendering and debug stuff working, so that I have something that always works, even if like UI doesn't work or anything is broken. And I tried to integrate this a bit with a font face and font manager last time, or I told it I want to do this, and that's basically what I started up. I created a new package called UI util, and UI util basically is everything related to UI, and it's a util class. Later on, this is going to go into a general UI package. I personally don't like UI util from the form. It's going to be UI and the namespace util or UI subfolder util. That's something they're going to change here, but I've just added this, and I created a font manager. The font manager's purpose is to open font faces by getting a path to a font. Now, this path here is a special path. These are going to be paths that are going to be specially handled in the engine, not a normal Windows path, but it's something that we're going to get to it later. Basically what it does, it creates a free type library, and open font face returns a font face. And a font face is basically just a wrapper class around a free type face, including some states on what the face is currently, which state the face is currently, so that we can work on that. But this is currently not working at all. I think the only implementation that we have here is move assign, move construct, destructor, and all the functionality is not implemented here. The font manager currently supports like creating itself, moving itself, destroying itself, but not opening faces, because that's something that I need to implement. Before I can implement this, I need to get file systems working. I could use like the normal C file system path to open it up just with a normal C file and just use the path, but that's not how I want to use it. I want to open this up properly. Alright. Normally, the English subtitles should be generated by default. So I know it's a stream, so on the stream it's not doing it live. I don't know if YouTube is doing it after the stream, but it should do this. Is it adding subtitles to live streams after processing them? Let's see. Yes, it is doing automatic English subtitles also for the stream, so English subtitles should be there on all videos where it auto-generated these. YouTube didn't really generate, a few videos didn't have the subtitle generated because somehow I think it was a bug there that a few of my videos were tagged as German videos, but they were actually English videos, and so the subtitle was not generated correctly, but I cannot like tell YouTube to regenerate them. It's a bit sad, but yeah, that's not working. Alright. So font manager and font face should later on be the classes that are there to access the data of a font. And then basically render this somehow into an atlas, and they should have all the util functions to be able to render it into a 2D atlas. Or 2D atlas, however this class is going to be called, but basically just a sprite sheet. And yeah, what I then knew here when I started with this, I knew that I now need to implement file systems, and I also want to implement them directly correctly. So what I've created is a new package, the file system package, the contract package, and what I've created is a new contract, and the contract is the iFile system. The iFile system currently does not have an interface because it's in progress, but the idea here is that we have like a common interface for a file system, like opening files, checking if files exist, enumerating directories, and stuff like that. Enumerating files, and all of that is going to be a file system interface. It's also going to get an iFile itself, an iFile object that's created when the file is opened. These are all going to be H objects, so that they can be referenced throughout the whole application, and they are ref counted, so that you can basically create a file, and the file is then going to be kind of like a descriptor that knows its implementation of the file system and how to open it and how to work with it. And then you have this iFile object, which is going to be a descriptor, and then you can load this to memory and do stuff like it. And implementation under the hood depends on like the operating system, or actually even an implementation maybe in engine. If we later on have our own packaging, then a file itself is still going to be a file, but it's going to be by the packaged file system, and the packaged file system uses the operating system's file system to load it from disk, and then it's going to extract metadata and decompress it and decrypt it, whatever it's going to be doing there. Now I have started writing the Windows file system. It's completely empty currently, but this is going to be populated with information for Windows. Now I've changed the HObject handle now actually to also support assigning raw pointers to the object, and it's just going to call addref. Because if you want to create a new object, you're going to get the address of the pointer inside of that, so the address operator. So this was not really a big deal. Alright, so next thing that I've implemented is the file system registry. The file system registry is in the engine's util package, and in the subfolder file we have the file system registry. The file system registry is responsible of registering all file systems and mappings. Now basically the file system registry is gonna own all files. File system registry can be, I think, is it a singleton? I've deleted the copy, made the default. No, it's not a singleton, but we're gonna have it somehow stored. We're gonna have a default file system registry somewhere. Not quite sure on how I want to do this. If I want to do it with, I personally don't want to really do it with don't want to do it with a singleton, because this has some initialization in that, and I want to have static initialization near 0. I don't want to initialize an unordered map there. Now, what can a file system registry do? It can register a file system, which is returning an FSID. So you register a file system, you're going to get back an ID that is associated with that specific file system itself. you can get a file system by the ID, and you can map the file system. Now, how can you map a file system? You can map a file system by specifying a drive name and the target file system. The drive name is gonna be a virtual drive, so we're gonna have multiple drives. For example, if you have the package of the application, it's something like kind of like game data or game/a path, and game is then going to map to that file system, which on debug is being correctly registered to the normal system file system, and on release is kind of like registered to the file system that loads the packaged data, decompresses it, and works on that. Mapping can be done in two ways. You can map it by specifying a drive name and the target file system, and you can map it as an alias by specifying a drive name, a mapped drive where it's going to be mapped to, and a root path. So for example, if your packaging works by having multiple packages files for each level and own package, for example, then you could map the level name by providing some like level name here as a drive name. The mapped drive itself is then going to be the actual game data, for example, and the subpath is going to be level 1, something like that. And for example, the packaged file system then basically knows that the first folder is kind of like the package where it needs to load it, and then it's going to perform the intelligent stuff on that. So mapping the file system as alias or as a direct map. Set default drive is very simple. If you don't specify a file system for the resolve function later on, this is just going to take that one as a default. Storage, it's very simple. We have this FSID, that is the next SSID that's going to be selected. We have an unordered map where we map FSIDs to file system pointers, or not actually pointers, but object handles. So object handles that are ref counted, or yeah, object handle is kind of like more like the guard class for that, so that we have automatic ref counting there. Unordered map here as well, the STD string to the drive mapping. String is going to be the drive, and the drive mapping is going to be the mapping, and here we have an STD string of the default drive mapping. A drive mapping itself is first specifying a type. The type can be mapped to file system or to other drive. If we are mapping to a file system, we have a pointer to the target file system, now not in handle because the handle is not needed here, just a raw pointer. And we're basically mapping to that file system, so that we know which file system to ask for, and you can see that I've planned to use the passes like that. So we're going to have always a $sign, and the $sign is going to indicate a drive on our engine, and $sign, name of the drive, /pass is then going to basically how this is mapped. You give it a name, and this name is basically resolved to the file system pointer, and the pass is then requested from the file system pointer. If you are mapping this around, then you basically have this name and the path specifies. However, this is going to be mapped to a mapped drive and the root path, which basically makes another request for the map name, the root path, and the path specified by the user, so that these get concatenated together correctly. And what we can also do is we can resolve passes by using the resolve function. The resolve function basically gives us information that we need to actually get the file system and the real path which we need to request. So if we take a look at this up here, a resolved path has a pointer to a file system and a final file path on how it is mapped to that file system. It also has an inline operator bool that just checks if it is valid, so that we can check that this. So if basically the file system is null pointer, then there was an issue. And this is how it should work. Implementation is very simple. Register file system, we just get the old file system ID and increment it. And then at the old file system ID, I'm just going to assign my file system there, and then I'm returning my FSID here. Get file system, very simple. We try to find the ID. If we are finding the ID, we return second, and if not, we're returning null pointer. Mapping the file system, very simple. First of all, I check if my mapping has been found, and I try to find my mapping by the current name, and I try to find the file system by the target file system. The mapping need to be at end, so the mapping does not need to already exist. If the mapping exists already, we can't map it. We could try to remap it, but maybe we're gonna do this later. And the other thing, the file system is not allowed to be at end, so the file system must exist and the mapping must not exist. This is asserted by that if. And then what I can do is I can get a reference to my new entry. So I go to my mappings and basically create a new entry, have a reference to that. Then I can set the type to map to file system and set the target file system pointer to the pointer of the actual file system. Mapping to a drive is very simple. We just need to check that we can't find the mapping yet, and then we also create a new entry, set it to map to other drive, and assign the root path in the map drive. Very simple. Set default drive, also just string assigning here. Resolving is a bit more involved, but it's also not that hard. First of all, I'm creating my resolve path as an object, rpath, and then I extract my analyze string, which is gonna be the generic string, and I resolve my mapping name. By default, my mapping name goes to the default drive, because the default drive it's actually not the default drive, it's more like the default drive mapping, but I'm still assigning it to the default mapping because this is like the fund that should be used if we can't extract something. Now what I'm then going to try to do is I'm going to try if a drive has been specified by the pass here. I'm doing this by checking that the length is bigger than 1. If it is bigger than 1, we know that we have at least 1 char there, and actually 2 chars, so yeah, it really doesn't matter. Like, it could also have something like 5, because passes should have a certain length actually. Now, what I'm then going to do here is I'm going to check what the char is, what the first char in my analyze string is. If it is a $, then I know a pass has been specified. If it's not a $, take the default mapping. But if we have a $, use it. Now the drive is specified, and I'm trying to find the first of a normal slash or a backslash. Depends on what operating system you are on or what you're specifying in your code. I just want to be able to work with both. So normal slash, backslash, I don't care, find the first of these two, or one of these two. If I found one, yeah, set fpos, then if I found one, which basically means that we are not npos, then we know that the mapping is correct, and I'm extracting the mapping name by creating a substring of that. I'm starting at the char1 to cut off the $, and I'm going to go to fpos -1 so that we get the whole string in here. After that, I'm going to modify my analyze string, because now the analyze string that needs to be analyzed later on does also contain the drive, so I need to cut this off. So I do a substring by fpos +1 so that we cut off the slash, and we are like on the new path actually. And then I need to resolve the final mapping. How do I do this? I first check that my mapping name is not empty, so it could be empty if we haven't specified something default. If no default has been specified, it's empty, and if we wouldn't find a actual drive here, or didn't specify the drive here, then it's also still empty, and then I just don't want to continue on. But if we specified something, we now need to try to find it, so I try to find it by the mapping name. If we found it, we can check it. So we first check the type. If we are mapping it directly to the file system, it's very simple. The file system is going to be set to the target file system of the mapping, and the actual file path is now our analyze string, which might have been cut off. Map to other drive works a bit different. First of all, we need to create a new path. How is the new path created? We're going to take a std string of a $, and I'm going to pen to the $, the mapped drive name, so that we have $ mapped drive. Then I'm going to have a slash here, because this is a path. So we can have the slash here, so have the drive name slash the root path slash the analyze string. This is maybe something that we might want to check if it's empty actually. Yeah, that's something that I'm going to do quickly as soon as we're done. Because if this one is empty now, we basically have a double slash, and not something that we want. And the last thing that I just need to do, I just need to resolve it again. Very simple. Just resolve it again, because now we have the new path that we need to look up, and we're going to call recursively resolve to resolve it. And after that I can return the rpath to give it a final object, which now should have a file system and a path if it's valid. And if it's not valid, it's null pointer. And that's the whole idea. So, bit on fonts and file system. This is what I've done previously, and now we need to get started with the actual work of today. Now, before we are doing that, I want to quickly maintain our Trello board. Here we are at my development status of the Trello board. I'm not signed in. Okay. Yeah, let me quickly sign in here. I don't know, I should be signed in on Atlassian. I don't know why it's not doing it. Okay, there we are. Now signed in. This has been finished. It's not to do, it's actually done. This is also done. I couldn't archive them just so that we are on track. I need to more think about this and actually maintain the board. Alright, so but let's first talk about what we need to do. Okay, so for the engine I need to do debug. I think, can we do nested task? Debug text lines debug text and shapes. Let's just call it debug lines and shape. And this is to do. And I think actually work in progress because we are kind of working on it. Can we do subtasks here? I don't think. Okay, I could like do a checklist, but can I see this? To-dos. Okay, so what I would need to do is like text rendering. Okay, yeah, it's showing this then as like a 0 of 1. Okay, so text rendering is something that I need to do here. Then we need to have line rendering. Quad rendering. Rendering. So text line quad. I don't want to write around quad, maybe triangles. I don't know, I'm not quite sure if I can really do triangles because I think we're actually gonna remove triangles from here because this debug renderer is gonna be a quad renderer, a very simple quad renderer that can render texture quads. So it basically can render text because it's looking up this in a texture. Then it can do lines because lines can be just represented as quads as well. Quad rendering itself is of course already working. Now the question is if we do wanna actually render more involved shapes for debugging purposes. I don't think that's really necessary, at least for now. So I think I'm gonna stick with these 3 for now. So it's gonna be a bit more simple, but in the future we might also want to render a few more shapes like circles and stuff like that, what we can do with our own shaders. Or what we could do is in the future we might transfer this this UI renderer to an SDF renderer, signed distant fields. Signed distance fields basically allow us to scale our text a bit better, and what we can do is we can actually create a circle in signed distance fields, and we should also be able to create a triangle with signed distance fields. So what we could do there is then also draw these other shapes in here. We could also do like rounded quads and that, and we could create a few SDFs that are then also loaded in a texture atlas, which is something that we might want to do in the future. So here, let's see, for the future, maybe move to the SDF rendering and add more complex shapes. Then, okay. That's good. What is these amazing fields? I think I installed these because they were looking nice, but I might want to remove them later on. What is cover? You can actually add a cover to cards? Oh. Oh damn, that's not really... I mean, it's maybe... Is it useful? Nah, we're just gonna leave it as that, as is. Is it actually adding like a bit more description in here? No. I could add myself to that card, so then you know that I need to do it as well. Dates, and when do we want to finish this text rendering? I think today we're gonna be doing file systems, then maybe... Nah, I don't know. I'm not gonna get do due dates now. Because there's too many things to do. I can actually like... Oh, okay, this is upgrading the workspace. Okay, but I think for debug text and shapes, this is good. Now let's add a card for file system. Files, let's go to basic file system implementation. Alright, so basic file system implementation. This is gonna be to do and work in progress. Well, actually, this is just work in progress because we are currently working on, and this is still on the to-do state because we are like blocked. Let's add myself here. And we need to add a checklist in here. So let's call this to again to-dos. What do I want to add to the checklist? Alright, so file system implementation. I need to have registering and resolving files, or resolving files to file systems. So we need to resolve files to file systems, and yeah, that's what we need to do. Now then what we need to do is we want to have a Windows file system implementation on handle. So async file system, asynchronous file system, and then I want to have Windows file system implementation file system implementation DirectX storage DX. I don't know, how is it called? Is it called DirectX storage? Yeah, that one here. That is like the package of direct storage. Microsoft.direct3d.direct storage. And this is basically a C++ library for using Microsoft's more advanced file system. And this is basically async IO. It's a bit more involved, so yeah. Okay, so we actually already have GPU decompression and G-deflate. So deflate is like the algorithm that we use. I think it's zlib, yeah. So zlib compression is gonna be already supported on the GPU. That's amazing. So we already can do zlib. Okay. So we could directly load zlib from disk to GPU actually, but if we do this, we need to have the unencrypted zlib data in a file, I think. Do we have actually documentation for these functions? Because I'm still like planning a bit on how it should work. So GitHub, okay. Okay, developer guidance. Example, okay. Form a GPU deflat, thread count, compression. Okay, this is like a factory. Okay, so uncompressed data flow. Okay, this is something that's interesting. How we want to do this? System memory. Source uncompressed staging buffer mem copy destination of an IOP, and then it goes in here. And we can do this also directly with uncompressed to GPU, so it directly goes into an upload heap and then it goes to VRAM. Or we can have custom compressed data flow. So staging buffer, decompress destination, staging buffer, decompress upload heap destination. It's very simple. It's how you would implement this on your own as well, but it's going to be a bit more easy to do. Compressed data flow. Okay, SSD, IOP, staging buffer, decompress destination. Upload heap, GPU copy, input staging buffer, decompress output staging buffer, GPU copy destination. Okay, so this is like, this is where we accelerate with direct storage. Actually, do we? Normally, like there wasn't there the thing that it should directly load to GPU, or was it just RTX-IO? I think this was RTX-IO. Oh, come on, I don't want to zoom in here. Yeah, because like this is, if we have a staging buffer, we are still going... This is Nick. Why should this go over Nick? Or is it a storage Nick or whatever? I don't know. Network interface controller. I know Nick is network interface controller, but this is maybe in a different meaning here. So the idea is basically normally storage, NIC, PCIe, CPU, system memory, and then to GPU memory, which is still like the path here. It still goes over system memory. So RTX-IO is the library. This is like, this is actually what I want in the future. NIC, PCIe, GPU memory. But seems like that this is not supported yet on direct storage. I think it was. But still, this is already giving us an advancement here. Overgang of an upload heap with GPU copy and GPU copy. So the idea is that we need to support these data flows with our file system. Okay. Now the big question is more, how can we handle async and sync storage now? It's more the question of today. Alright, but I think... Actually, like, do we even wanna use... Do we even wanna use a normal default Windows? I kinda like think yes. We still wanna use normal Windows copying, we still want to use normal Windows copying in case we are having issues with direct storage. I think. But in the future I'm more like, I personally just want to go like direct storage all in. But I think we're going to start by implementing a very rudimental file system. Especially like for our game data. For our game assets we want to use it. But maybe we're going to do something with Windows file system and a Windows implementation. I know. Or we're just going to implement 2 Windows implementations. Yeah, I think we're going to start with having 2 Windows implementations and see where we are getting along. Okay. No, Visual Studio is not yet open yet. Okay. So let's start by opening up our solution. And get started developing. Which of course opens on a different monitor. As always. Load my solution. Why is it loading so slow today? Alright, there we are. Okay. So I need to first fix something here. No, I don't want to select the folder. Interesting. Oh, okay, Visual Assist wasn't loaded yet. So, now we are working. Alright, so first let's fix that one. So basically what I want to do is we want to say... something like that. This should do the same trick. But now I'm gonna check if it's second root path empty. If this is not empty, then I wanna append this one as well. If it's empty, yeah, screw it. So that this one is implemented correctly. Now we could actually try out and check. Yeah, we can actually already check if this code works. I think this is currently completely untested. I didn't have the chance or the time to test it. Testing is wrong, I've learned in university, because we're not testing. Ha ha ha, yeah, but we are like trying out if it works. So PDKEngine, util, file system registry. Now let's see. Actually, free type is still in here. We don't need free type here. Or we might still want to have it in here as a reference. Okay, so let's just keep it here. Alright. So let's do some... Okay, DPI is kind of related to free type, so let's do a bit of file system here, and we're gonna have a PDK engine file system registry R. And then I wanna register and file system. I do just now register null pointer. I hope it works. Or actually, no, let's not register null pointer. Let's actually register a pointer that is at some arbitrary... Does actually autocasting work? Sadly not. That's actually at an arbitrary value. Is it in Hull? Yeah, I file system. There we are. So we're just gonna register file system. Let's get the ID of the file system here. And now we have a file system registered. Now, registering a file system doesn't really do a trick. Now we actually need to map this file system. So what I want to do is I want to map a file system. Okay, so we have two overloads for that function. Come on, why is my IntelliSense screwed? Visual Assist, please. Okay, there we go. So first of all, we need a drive name. So what's the name that we want to use here? And then I actually want to map directly to the FID. So let's maybe call this something like root. So let's have like the... Actually, what I do want to do is I want to have this always caps here. This is currently not implemented that it asserts that, but I'm just going to write this caps here. Or let's just call this PC because it's for the local computer. Or maybe we should just call it local, so it's for the local system, a pass to the local system. Okay. But what I also want to do, let's have this one at... Let's map something to a working directory. Which would be something like that. So now we would basically have work, local, root pass. So now local should be every pass local on my computer should now be resolved by local and then provide like see my file whatever. And if I do local, I should have / resolved. So let's try this out. Let's try it out. But it's still the same file system, okay? So let's see what we can get here. So my idea is now to have a file1, and file1 should be equal to rresolve. And I want to resolve my... Now this one is of course not going to work because dividing doesn't work. So I need to actually do it like that, but this is something that should come in the future. Later on we're going to have default mappings that are like defined in the header, and you would just have something like pdkfs local, and then you could do / because this pdkfs local would be defined somewhere. We actually do this. Let's actually define them very quickly here. So this would be something like that, and then we would have... What did I call this? Local and here? No, work. I should call it work. Work. There we go. This is how I would have this defined. So, oh, didn't want to cut this out. So that I can like say something like pdk local and then c / what passcode we use. Maybe some... Let's see what I can find on my system that's actually existing for the tests. System root C. Do we have something here that we can mess around with? Installer debug.txt, but it's not that far away actually. Install anywhere. Let's go to my users directory and to my saved games. Maybe here CD Projekt Red, Cyberpunk. Oh my, 1000 saves. Actually, I've had like many backups of my Cyberpunk saves because they had a few issues with that. This is the GLS. Let's reference this user GLS file. Come on. This is sad that I can't copy these. Let's do this like that. So let's copy them down in here. And then the idea is that you can put that one on here. Like that. I mean, yeah, I could do the... Actually, let's do this on how ST file system is meant to be used. This is how you should use it, right? I could like say... Now I can put in a file. Users.gls. To open this file. And what I can also should also be able to do is also do a local file. So if I want to have a local file, I would use ptk fs working directory dummy.txt. And now these should both resolve to a Windows valid path. That's now the idea. So let's make a breakpoint here and see what we got. If I probably made some bugs still in the code. Except that semicolon. That is for sure a bug. But the other code is probably already bugged. Oh, okay, yeah. That was sure. Yeah. Okay. I forgot that I've used an actual H object, so we need to actually have an object of which is actually a file system. We need to have a file system. If we don't have one, it doesn't work. Okay. So engine, hardware abstraction, implementation, Windows file system, Windows file system. So let's just out of curiosity just create a dumb ass Windows file system. I hope I have all code for the Windows file system together that I can do this. Windows file system. No, I don't have the code together that it works. So let's do a quick. My file system. You should have that memory allocator forwarding stuff in here. Which I do just want to quickly copy over. Why are you not allowed? Okay, yeah, okay. Okay. So now that we can forward it, we can use it. So let's go into my minimal app and let's create one. Okay. So ptk HAL Windows file system. But this needs to be a pointer because it's an H object. Or actually, we need to do it completely different. We need to do it and I have a handle for that. Now we need to create it. You have a problem with that? Is it not included? Oh damn, where did you edit that include now? Okay. Yeah, this might be something that we can have in here because it's probably needed. Still? What is your issue? It's a PDK? Okay. Hello, welcome to the stream. Following. We just need to create this one. So, new object. Actually, how did I implement it in new objects? Now I've changed something on my handle. Did I screw something up? Dereferenced. Okay, so we had a pointer to a pointer. Okay, and then this was dereferenced. So we need to actually get a bit around that. I'm currently working on adding file systems and having the option to actually have multiple physical file system implementations, like a Windows file system, direct storage file system, packed file systems, whatever you kind of like want to have in a game engine for also like distributing, saving the games to an actual specific save game location and fixing it, having multiple file system implementations that are working with just one abstracted interface, and being able to correctly manage them, registering them with like virtual drives inside of the engine, and have them all resolved to a correct path that is valid for a concrete file system implementation. Which I'm currently doing here, so I'm currently like creating a new file system, Windows file system implementation here, which is currently not doing anything, but I still need to do it. Need to do it actually in this. Need to extract the normal pointer to that, so I can assign that. Actually, we could do this. Like that. So now that we have initialized it, now I've created this new file system object. I try to just use a dummy pointer because I don't really want to use it yet, but I have forgotten that I made this actually a managed object, and the managed object of course needs valid data. But like that I can create a Windows file system, or should be able to. Which shouldn't have any ref count, but it should be still valid. So let's take a look at what we got down here. So WinFS is a correctly ref counted object now, that's good. And now I should be able to create my file system mappings. And the file system should have one registered file system, which is my Windows file system, yeah. And now we have a ref count of 2, which is correctly, because now one is referenced by the file system registry and one is referenced by my handle above here. So this is why we now have a ref count of 2, that's correct. And now let's just take a look at the mappings. We should have 2 mappings, work and local. We're looking good as well. Now let's see if my mapping code works. So let's take a look at file 1. Both of them should have a file system associated with them, but they don't have one. Okay. So file 1 was invalid and file 2 was valid. So what did file 2 look like? So the file 2 resolves to ./dummy.txt and my file system. That is actually correct. Yeah, and I have this like partly planned out, but not like hard planned out, but it's still like have a bit of a plan there. Yeah, so have fun working on the web panel. Yeah, that's sad. Code doesn't work always on its own. Okay, So we have a bug in that code actually. So let's jump in and see if we can find it. Okay, so how does these strings look like? Okay, the analyzed string is the full path. Okay, now... Okay... The double point slash did not resolve correctly. Okay, so what's the matter? Is it not how files? Can I not have? Why? It's not fun. Yeah, depends on what's not have working. Okay, so STD file system does have an issue with the idea on how I want to do it. How does it look like if I... So this works. So $/work is good for him, but the pass C double point, it has problem with that. Move that one. Does it then work? At least like resolving it? It works. But why can't you... Why does that not handle... Do I need to do it differently? Do I need to do something like... Would that work? Now I'm trying to do it with C double slash. But it doesn't really work. Why is it not possible to... Okay, so having it as a C drive does not work. But this is something that is not solvable by me. This is something on how STD file system works, I think. But let's try something out. STD file system pass pp equals 2. There's saved games. I mean, like, this is just a dummy file. It might be a bit bad to just use that one, but yeah. Let's see what you might having an issue with that. How does my PP look like? Okay, so this works. So you're only gonna have an issue if I add something before that. So this doesn't work. Why? This should work now, actually. Yeah, the idea here is to be able to specify passes in a certain way. So, for example, there are certain locations on Windows that are used for example, for like saving games and stuff like that. This is why I am using it like this. So there might be also the way that I need to have an actual absolute pass. So if I, for example, later on, like in the editor, or if you have like an import function, or you are actually selecting a file, it can be that it is represented as a whole pass, and I just want to be able so that I can actually specify a full pass as just also absolute passes. local absolute passes. So yeah, local stands for local computer in this case. So yeah, so that you can have like a and can specify full passes, just like currently just some dummy in here that I'm testing out to have map file systems. Can map them around. Just want to be able to do this, so yeah. But why that one works, but that one does not? Maybe because we're concatenating and here we are directly putting it a string, but no. Probably we are violating something that STD pass is trying to. Plus I need to jump in. Yeah, it's striping that away. Let's do this differently now. Is it because I'm using the concatenate? Yeah. Or could I... So if I concatenate the passes, it seems like that... Seems like it's not happy with that. Oh, it's happy with that, but it stripes again away my... Well, okay, so... I would need to do this differently. But if I would hook this up as a default... If I would hook this as the default pass, this might work. So that I can specify like my C users pass by default. Do it like that. And we have a real pass, that should be no problem for you, right? And then I can have this one as a default, so I can say like our default is local. This is hopefully gonna work. Still stripes away, so it doesn't like that. Why don't you like this? I mean, like, C is a drive on Windows. It's not that it shouldn't be something that's there. If I do it like that... Of course you need that one again as well. This works. But it can't work with like the normal C slash. Interesting. And if I add this one before, it's gonna fail again, right? Performs validation on that, or what is it doing? Interesting, it's just ignoring. Because it kind of like thinks that we are restarting the past. That could be a thing. But if I would do it like that, would you then accept this? But this is like something that's probably like out of normal behavior. It's probably like undefined behavior. That would work, but I think this one, I think it would be better if you would do something like that and then have it as a default pass. Is there actually, that's something that I might need to want to actually look at. If I would resolve this, now this should probably work because I now set this up as a default one. So this is how you could actually do it. So this would need to go into a macro later on. So it would have like a drive macro. I have like DP. DPX, something like that. But X would be, yeah. You could like do an SD file system. Pass of D. P. X. Oh, I just completely get this out of the way. So the users would look a bit cleaner. If it would be variatic, it would be probably nicer. Well, that's something that we're gonna do care about later, because probably you're not gonna ever in code specify a absolute pass, so in code this would never be a thing, and if it works, then I'm fine with it. Actually, yeah, this also worked. I mean, so yeah, it kind of works, so I'm good with it, with defaults. So yeah. At least we have like this mapping tested out correctly. So now just required to implement this on Windows to get a bit of file system implementation. So how do I want to implement this? First of all, the file system needs to be able to do something. So except of like opening a file, we need to have a few management functions. So the question how I want to implement them, because like we want to have like a open file, or actually like I do want to have just a file function with a path, basically an file at path, the signature, so that we can get a file of that, but the file is not going to be really an open file, so it's just going to be a file descriptor that has like all information about this file attached, and that we can then do operations on. And I do want to have something like an I directory enumerator. And this I directory enumerator should have an enumerate function, which is going to get the path, option, options, and maybe a filter. That's by default empty. The options by default enum like files, enum years. And this enumerate should then be able to enumerate files in a directory or directories of directories and files. And also on files I do want to have something like .txt or like .dot so that you can enumerate your real files actually. This is something that I want to have here. Then I want to have a few check functions. Path exists. It's going to check if the path exists. So file and directory. Yeah, for in terms of file systems, for the file system in general, yes. But I'm gonna have also like software-defined file systems and direct storage later on, and a few more advanced things going on there. So with like a direct encryption, not encryption, maybe encryption as well, but with a direct like decompression path, so that you kind of like access a file as if it would be a normal file, but in reality it's like inside of a package. The package is compressed. That package has its own thing. So this is like all why I'm doing this with like actual runtime interfaces and virtual methods. We do not want to call this path exists, just exists. Which when you check the file directory exists. And now this is currently just for reading. I think reading should be fine to start with, and then we can add writing as well, because the file system also gonna have access operators that can read, write, or both. By default, you can like read and write for Windows file system, but if you then have like the virtual file system that works on the packaged game data, you're just gonna have a read access modifier there, and write will fail. It's like the idea here. Now the question is still the I file, if this is the pointer. We cannot really have it as an H object, so we might want to have these as actual objects. More for base files. So this file could be a descriptor, so it could be like a file. The direct enumerator could be one as well. So it has like the path stored and maybe a handle to its implementation. Maybe you can see this in the future, because like the file, but the file might also have a state. I mean, if it's open, it might have a buffer, so it might also be good to ref count them. But the question is, if we ref count them, we wouldn't return an I file itself. We would then return an H object handle to an I file, so that we have ref counting completed function calls. And then we have bool exists. So we gotta start with that function, because it is simple. So that's the first function that we need to implement. Now, I think the default Windows file system should just be abstract to the Win API. And then we might have a more concrete implementation of the Windows file system, or an actually like restricted file system that might assert that we can't write outside of a folder. Might be something we want to do, but this might also be something that we're just gonna leave away, because it's like trusted code. Yeah, this trusted code. Alright, so let's maybe Okay, so the exist function. Win API. I haven't used Windows files for quite a while actually. We could try to open this because like pass file exists. This is like more something that I want to take a look at. Yeah, if it's valid, does valid means it exists, or that it is valid? Since the function is called exist, I would think it is checking for existence and not valid. File is not there, file is there. Okay. Good. So it does what I want to do. Do I have this already? Ah! No, copy. I don't think that I have that one in here, but I'm not quite sure. Oh, I did this differently. Yeah, it's not in there. Did I change something here? Yeah, the filters, okay, yeah, makes sense. Okay, now shell functions should be good. They probably also don't have to include yet. The Win SDK is also something that should move differently to a different location probably. Still coming from like the Win SDK in here from when we started and loading it with W Win main. Okay, so now we have Win SDK in here, and now we should be able to test this with. And actually, I do want to check this now with W passes. So that we are not limited here by the file system itself. So now we can check if it is implemented. Nice, deleted the semicolon as well, of course. Exists. Alright, so this one should be very simple. I mean, we currently don't have any extents that help us dealing with that, but what we can do is I could quickly again find a file, maybe something that's in my working directory. What is actually my working directory? That's a good question. I don't think that we have yet set this up. Let's see where we are. Okay. So we are in the source directory because this has not been set it up. Okay, project directory. So our build.lua file should be there. So an auto file should be able to resolve. Now, I mean local. Yeah, let's do this. PK fs work, and I did want to check for a build.lua file. And then I should have the same file implementation, and then I can like check my, or maybe let me do an auto. Path is equal to that, and I check for my paths. And then I'm gonna check auto exists for R. No, file system exists of paths, and I should get a true here. Okay, so let's see. Okay, let's take a look at the output. First of all, my path was work build.lua, that's correct. My file is having a file system with the correct path. Now my exist is false. Okay. Why is my exist false? Because this one should exist. Or was it not? Shouldn't the... no, damn. I didn't want to directly start over again. Because I didn't have my breakpoint in there. So this should be now. So why is that false? Isn't it called build.lua? Build.lua. That's exactly the right path. Okay, maybe we are on a different directory. Are we on a different directory? Where are we? We should be in project directory by default, right? Yeah. In here is my build.lua. Okay. Interesting. So maybe the Microsoft function does not what it should do. It's doing... It's not working with... Doesn't work with, like... relative paths. Yeah, I mean, this is C#, but I searched for that function actually. Evoke. Always returning. Nah. Get last error. We could try this out. Let's see. Okay. Last error is Let's make this a H result so that Visual Studio also knows what's going on. The system cannot find the path specified. Okay, so it's not like it has an issue, but... yeah, I'm a total idiot. Of course I need to check for file path. Actually, why is it called file path? It should just be called path. Yeah, of course I need to check for the resolved path and not that path that I inputted. Okay, but let me quickly rename this one. Where are you, util? Oh, we have to see as the correct path, and now we should also get true. Breakpoint. Now we are getting true because it exists, but .xlua should give us a false because xlua isn't a thing. And this is false, yeah. Okay. So that works. Now I care about maybe enumerating something. Let's first test if we could also just take a look at the folder, which should also just give us true. But it gives me false. How does the path look like? Okay, so this is a bug. It didn't resolve to dots, baby, because we didn't had a trailing slash. So okay, that's something that we need to implement as well. Basically, what happened is that we went into this else case, and in this else case, we want to do it like that. And now that's good. Okay. Yeah. This should solve that case. No, it's a real bug. But now it was not able to resolve the file system. Amazing. Okay. Yeah. Of course. We need to still cut away the first. Like that. Remove the first character from there. Now this should resolve to the right one, we should get a true. Yeah, now this works. And now we are getting to things where we want to enumerate something. Okay. Let's create a new header here. File system enumerator.h. Okay. Let's take a look at the file system.h. This this forwarding, I do want to now make this a macro actually. Because we're going to do this quite a few times. Oh, come on, Visual Studio. See a C forward, constructor forward for a class. And this is going to result in inline class. memory, PDK memory allocator, to dereferenced. Let's actually make this multi-line. H object is, I think, a PDK. Yeah, so H object of allocator. That one can go here. Right and cap. Or we might, no, we actually might not want to have them here in general, so that you still have the possibility to write your own initialization in here. I also want to have the forward A, which gets an argument. Which should basically just be that, but with the argument in here. Then you have like your allocator, and you can continue on with your argument. Now, how was variadic stuff done? And X with multiple argument. Now, was that variadic? I think yes, but the question is, how was it var list or something like that? The macro was, I think. Was it that one? I haven't used preprocessor for macros. Variadic macros, never used them for wire. Oh, that's nice, not found. Ah, underscore, okay, yeah, though, thank you. Var list was the default C stuff. Why isn't this not... Yeah, ... Hashtag was... Why is it not highlighting this? Yeah, I hope it's working. Then we can do it like that, and then the user can continue on adding their own stuff in here. C forward, argument, and argument X. Okay. So now what we can do here is, we could also try this out in the file system, because we want to forward the file system itself. This is now constructor forwarding for the file system here. But actually no, we don't want to have this different, because this is a default, this has a default argument. So actually we want to have the argument before we have the allocator. Same here. Like that, okay. Now the comment is also not required, and now we can plus I files enumerator. I think I called it directory enumerator, and I've completely screwed it up now. Okay. Directory enumerator. This one is already included by the H object, but now since we are not explicitly using them, it should be good just by having this in here. Public H object. Now we need to forward it, so I wanna say PDK H object C forward for the I directory enumerator. I want to have a virtual destructor. default implementation in here, and then it can be used. Now the I file system now requires my no, that one is not implemented, but that one is implemented now. I directory enumerator. Enumerate, and we're gonna get a... Actually, this one is more like a const pass. Even if I now need to redo this on the Windows file system. And then we are good here as well. Now we need the actual options here. The options are gonna be I should do them in a struct, or do I do them just with preprocessor defines? Yeah, probably there should be a struct, right? So maybe even instruct inside of here, which is gonna yell at me, but I don't care. So struct. Actually, like, these structs are like populating my global namespace, but they can be easily used to bitwise them together. Yeah. First. Let's just call this Diarinum. Option. Files. But I haven't. Yeah, of course. So 0x01, 0x02. Okay. What are all these spammers doing here? Stream chat. Files and folders. Okay, so you went AHT. Why doesn't this work? Can't you convert them automatically? Normally you should be. Oh, they're doing this in the directory setup. We are doing it C++ style. Right, good. Okay, no filter and all of that. Now we have the correct interface of that. Let's make this virtual and pure virtual. Now we are ready to go. Supplement the methods here. Of course, yeah, I love it. Again, that, all of the other ones correct, they work, but this is again, this needs to be in the PK HAL file system namespace. Yeah. File system, directory enumerator, yeah. But what's your issue on the Windows file system side? No issue. Just was whining a bit, yeah. Now the idea is that we have one on Windows as well. So first of all, let's go to the implementation of Windows because I do want to move the file. It's gonna be called Windows file system. I do want to have a subfolder called file system Windows. I mean, it's already okay. No, we can have a subfolder for more specific versions of the file system later on as well. So let's put the root in here. So we have the Windows directory enumerator. Enumerator.h. Okay. And we didn't. Okay, no, but this this forward is now because we need to forward through. Okay, so let's try and change a bit of my. Let's add a forward into all of these arguments. To whom we want to forward. And one to who we want to forward. This is down here, the forward. And so that we don't break compatibility, let's add them as F. Forward argument and format that, and now I want to have the old versions there as well. With CLS and PDK H object. Now we're also gonna have a I argument and an X argument. So arc variadic. So the arc is on the last thing. The variadic as well. Alright, so now this shouldn't break something, but we can say where's the X? The X should be in here. It should be like that. Now we just need to forward to that, so forward argument and forward X. And forward F. No, there should be an F. Okay, now we're on track. So to F, forward argument, forward X arguments, and the default ones that are mapping to these with H object. Now I can use them here as well, so I can use PDK H object C forward to for the Windows file system and file system I file system. Now we should have the correct implementation there. Yeah. And this is basically all that I need for the directory enumerator as well. No, it's not a file system, it's a Windows directory enumerator. And it maps to the I directory enumerator. Here as well. Windows, okay. That one, correct. So now just remove the functions because they're not here yet. And we are done. We have the Windows directory enumerator as an object. Now this one can create a handle for that. So a pdk h object handle of a Windows file system. Implementation, Windows file system, Windows directory enumerator. We can do a Windows directory enumerator here. Enumerator. And then what I can do is I can say dereferenced reference to enumerator. It's gonna be equal to get allocator, new object, and I want to have a Windows directory allocate object, and I want to get my allocator here. Okay, so this is not a pointer. Arguments are PTK memory allocator, object type is PTK Windows directory emulator. You are taking a PTK memory allocator reference allocator, so this should be good actually. But what is your issue? You shouldn't have an include problem. Or do we have one? I file system should have all the references solved up there. Hello and welcome to the stream. The H object itself has... Okay, so we might need to reskin the solution. But this is still not fixing it. What would happen if I add the include? Yeah, probably not changing anything. This is like a variadic issue. What is your issue here? New object. Is default constructible? No. Because I have an argument in here. Actually using that one. Okay. We need to explicitly pass the reference in here. std reference wrapper. Yeah, okay. Now if we have it as a reference, it works. Now we have created our enumerator. And now we can return it. Now we should be able to just return my enumerator, and this should now be castable, but I might need to call the get function to get the pointer from there. This is then converted to a new, this pointer is then convertible to the interface pointer, and the interface pointer is used to initialize a new handle, which is gonna call addref, and then the old one here gets destroyed. Okay, so we should be able to create it as simple as that. One thing that's now left to do is to actually pass the options, the filter, and the path in there. And this needs to go in here. So currently we had this in the... We had the... where is it? File system, and we had this in here. Now this enum needs to go away from there, and this enum needs to travel to the directory enumerator. Enumerator options. Yeah, we can have this globally. And now this is good. Now we have it accessible everywhere. Now we just need to have it as a Windows directory emulator, and I want to create a file. Now I do want to have my std file system path in here, which is the search here, so the directory where we want to actually search that. I want to have the option, enumerator options, and I want to have an std string of my filter. I think these should be already deleted by the H object. Let's see. No, I implemented something for these. The H object is okay. It's yeah. Let's delete them. Now I need arguments. The args are on the right. So arguments are gonna be a const std file system path and enumerator options and a const std string view reference filter. Now I can say actually H object. Okay, I want to have this a bit more macroized, because basically what we here have is we have this initializer list, and I want to have a pdk H object il append, and this il append is gonna do it like that. Options. Let's search here from path. My filter from the filter itself. So now we can have like append them in here, And now, why do you have a problem with that? This is in here. Okay, but it's a PK. Okay, PK HAL. That's in HAL file system. Okay. But it's in HAL, so just file system. Numerator options. No, wrong window. So now I should be able to create this class, but of course it's not gonna fail here because we can't create it because we need to pass on all these options. So I need to pass on the path options and filter. Then this should work again. Here as well. Then I have it implemented here. Now I should be able to create that object, at least. It can't do anything yet, but it should be possible to create it. So auto IDA für directory enumerator, and we want to enumerate from the path. Let's see what we'll get. Okay, we're getting some errors. Okay. Okay, so fx doesn't work. Don't you know file system yet? Okay, as simple as that. Now, let's take a look at my EDR and see what it is. It is an object handle of an iDirectory iterator. That's already good. And it's an H object with ref count 1, so ref counting works. And it is a Windows directory enumerator, and the search directory is correct. It searches for files and folders and has no filter. Okay, so this works. It can successfully create this object now. Okay, now we just need to get started with the enumerator. And the enumerator is always going to start at an invalid state. And what we basically want to do here is we want to move enumerator. Really, it's an iterator, but it's not an iterator because it's using the enumerate functions from Windows. To next, first, the next file. Start if not started it yet. So we're gonna have a boolean next function, a virtual bool next, which is basically bool it to the next, and it's returning true if it was successful. And we're gonna have an enumerator type, the file and folder. So I want to have a virtual get type also have a null type in here if we are calling this on an invalid state. So next, I get type of the current one, and I also want to have a virtual std file system path reference. No, not reference, just an std file system path. Get current path, which should give us the current path of the object we are enumerating. Now, this is gonna resolve in kind of like an issue, because the current path that we are enumerating, it's not like we can't do it with the current path. We need to do it with get relative path. It needs to be the current relative path. It's important because and then it's kind of like a string, but I don't want to like restrict myself to wide or narrow strings, so it's going to be a path. Relative path, so it needs to be relative. If we wouldn't have this relative, then we would have an issue, because we can't do reverse lookups. Basically, we need to do reverse lookups through our file system registry, and that's not how things work currently. So we would need to pass on that. This wouldn't work because the file system can give us multiple routes and things like that, so it wouldn't work. Yeah. So let's see how we implement this on Windows. Find file. Okay, do we have WinSDK already in here? Okay, so how was that function called? Oh, list file. Find first file. Win32 find data. User32.lib. Which we haven't included yet. I think this is it a point? No? So we have find data here, and we do have an handle for finding this. Do we have actually an invalid handle value here? Yeah, because it's actually -1 if the handle is invalid. I think I haven't checked this correctly in a few other things. Or was it actually in the... I know. Okay, but let's do it like that. So we have the find data and the find handle. And now we can work with these. But it's not in the file system. Of course. It's here in the directory enumerator. So this is like my... This is like my start condition. And now I need to implement the functions. File system enumerator type. These are the functions that we're looking for. Now we need to just implement them in here. Now the next function is very simple. If find handle is an invalid handle value, we start, and else go to next. And I might want to actually store if we already started. Bool started. It's gonna be false, and we only start if we haven't started. And if so, we actually want to say if started. Started like that. Do we want to start, and else if not equals that, we're gonna do that, and we want to return false by default. Now how do we start? Find handle equals find first file, W, file name. Now this is going to be a bit more involved because we might need to build this file name first. All right. Question mark. Let's see. So what we want to do is we want to take the path. Actually, we want to first append something to the path. So my search directory, I want to append the filter. What? My filter, of course, yeah. So if my filter is not empty, I want to append the filter actually. Which we can directly do. Now I'm going to do it here. And then we're going to say that my search dir W string, C string, and find data is going to go to find data. So now it tries to find, and then this is good. So now find next file. Find data. Find data. So this is to find the next one, and if this fails, first of all, if I started true. Now, what happens if this find? If this is 0, then we are at the end. Okay. And if we are at the end, we want to close it. And then I want to say that my find handle is the invalid handle value. But since this is it? So it does it with that, and then it tries to find it, and if it's 0, it directly breaks out. Yeah, okay, works. Okay, that's good. I want to have a destructor. And if my find handle is not equal to that, find close, find handle, invalid handle value, invalid handle value. Now I mean here it's not really required since we are destructing. So it should be good like that. Might want to check if data is valid. Yeah, let's do it. Data valid, false. Okay. This is set to false if next fails. Or could we also assign this one later here, because assign that here, then return that the data is valid, because here we are setting this to false, but if we are setting this to invalid handle, this is going to go false as well. If we started and started was correct, this is going to go to true. Okay. However, what happens if we have started, but find handle value is invalid, then yeah, it's going to be the same one. Okay, so this holds up. Bring exceptions in here. No check and throw. What the hell? Why do we have so many spam today? I don't know. So check and throw data valid. So directory enuma data not valid. Now how can we check the type? So find data. The file name is very simple, we can directly return this here. It's going to be automatically converted. So first we want to check if it's directory. Actually, we already need to check directories up here if we are even allowed to find them. So actually, after start, we need to actually validate. We need to validate the find data. So we first need to do that. Check if entry needs to be skipped. And how do we check this? Well, additionally to the find data, we actually store what it is. So file system enumerator type. Find type, so the current find type. We can actually return this then directly here. Evaluate type and skip if required. So how we're gonna do this here? So first thing that we're gonna do here is we need to check where it is stored inside this find data. Come closest. I think it was inside of the attributes. No idea, but I think. Okay. Okay, so we have directory, archive, directory, device, directory. File attribute normal, that's what we are checking for. Sparse file temporary virtual, pinned, unpinned. Really just care about normal and directory. So if my data valid. So first of all, we only evaluate if we are valid, and if find data attributes. If that is the case, I'm gonna say find type equals, give me autocomplete. Nah. Enumerator type folder. File find data, file attributes, and file attribute. Actually, it's just an else because everything else is a file. And if it has some other flag Z, or the normal flag is not Z because the file is a system file or stuff like that, I just wrote it like that. So check for the file. Now we need to check the skip condition. Actually, no, we can directly do this like that. So if options equals file system options, so we just want to have files. If we just want to have files, we want to skip this. So I want to actually return next here. I directly abort here and I go to the next file. And if my option specified that we want to have just folders, also just gonna return next here. Alright. And if we are on folder, I also might need to check something more, because as far as I know, Windows is also returning the current directory as just a dot, and the previous directory is a dot dot or something like that. And these two things are cases that I also want to skip. But this one should already work for us. Let's test this out. So let's say while edir next. Edir next. Like that. So while we can get something new. And let's say auto ti for type is edir edirectory get type, and auto t p is the current path, get current relative path. Let's see. What the hell? Oh, yeah, okay, but makes sense. I thought for a second I was in the Windows file system and the Windows enumerator, but it wasn't. Okay. So next directly failed. Okay, so this needs to be debugged a bit harder. Alright, so now let's go into that. So the next functions. We didn't start it and we are not empty, so my search directory is a current path. And find handle returned a invalid handle. Okay. So why did we get an invalid handle? Can we not enumerate from the current path? Or do we need to populate the find data? So let's see what get last error tells us. Or we might not have found anything because we haven't searched for a star. We might need to search for a star. Let's actually... Yeah, let's try both. We'll append a star. If the filter is empty, we are appending a star by default. Let's see. This might be something. This might be the issue actually, because it hasn't found anything from the beginning. Yeah. Okay. So this was already the error. So let's see what we get. Okay. So let's take a look at this. So TI, the type is a folder. And the PT is a dot, which is the current folder. This is the one that I want to catch. If I go again, we have another folder with dot dot. If I now continue, we have a file called build.lua. That's correct. If we're going to continue on, we're going to have the main.cpp file. VCX project, user, cpp, age, and we are done. So this is actually correct. Oh, actually, we are now here. Okay, so this is working now. The only thing that I now need to stripe out are the dot and dot dots because I don't like them. These are only going to be there if we have a folder. So if find data, okay, now we need to string compare. So we could also already extract this find path. So let's do the file system path find path, and use that one later on to return it. And what we do is, if the data is valid, we say find path equals that. So we extracted that, and now we can check if this one is equal to the dot or it's equal to dot dot. Generic string. What? Oh, okay, I'm an idiot. Okay. So we want to skip these as well. If I do it like that, we should get something. Directly start with the build.lua file, what should we do? Then we should be able to cycle through. So adding these lines here is what I've done. the find path here, extracting this directly and returning it here, caching it, which would actually render this useless now in the class itself, but I'm gonna, yeah, let's extract this one. We don't need it here. Now we are good. Now the only thing left to do is to check if it works with folders. So let's add a folder. Ah, not a filter, you idiot. I don't know why Microsoft added this filter stuff, it's useless. Folder, let's call this test folder. I mistyped it, but that's not a problem. And now if I would take a look at this again, I should get my test folder, build.lua, main.cpp, and a few files. Let's see. Alright, so we start with build.lua, which is a file. Main CPP, minimal app. And here is the tester folder. Okay, so it was able to enumerate everything in here. Now we're gonna try to stripe off. First, let's start by just enumerating folders, and now I would expect to just get my tester folder. Yeah, and we just get the tester folder. If I continue, yeah, we are done. I just added here the enumerator options folders option here. If I now change this to files and rerun this, we should just get the files and the folders. Now we have a file. Main CPP, yeah. Works, just the files. Which is exactly what I wanted. I wanted to be able to use the selective. I want to have files, folders, and everything. You know, I could also try to filter these, so maybe just try and filtering everything .cpp. So star.cpp, let's try adding this in here and see if this works. So we should get the build.lua. And we are getting main.cpp, minimal app.cpp, and this should be it actually. Yeah, and that's it. So filters work as well, which is exactly what the purpose of that was, of the interface, so that we can later on, for example, filter all the files that we need. And now the only thing left to do is to actually make this, let this file handle be a bit more convenient in how it works. This is something that I haven't done yet. So file system here. No, file system registry.h. Yes, where I want to have b. So inline auto. Let's do this with auto now. Actually, inline auto exists. And what is this gonna do? It's gonna call file system exists with path. Why is it now void here in auto? That should be bool. Yeah, let's write this out. Ah, it's void because I'm missing the return. Yeah. Inline auto enumerate Marate there, like that. And we are returning file system enumerate with path and enumerate options. Options. Let's add them in here. Add them in here as well. Let's pass them on. Let's do a const std string view reference filter, which is empty. And now this enumerate function should work as well, but it should make things a bit easier to call them. Because now they are basically callable on the object that we are getting, and we don't need to have this indirect call here, so we should just be able to call file.enumerate and stripe away the path. And we should be good. And that's it for enumerating. Now opening the files is actually something we had quite spent some time on that small features today actually, so I need to already end the stream. Still have something to do today, but thank you for watching, for attending the stream, and yeah, we're gonna see us on the next stream and next video. Actually, the video would come out today, but I think since we had the stream today, I'm just gonna release it tomorrow. It's gonna then not put too much stress on my video schedule. Alright, so thank you for attending the stream, hope you enjoyed, and I wish you a nice day, and see you in the next one.